In this video, we're going to take a look at some statistics questions in which we are given a grouped frequency table, like the one found here, and we are asked to find the mean of these figures and to find the standard deviation of these figures, and then to do a bit of work with a bell-shaped curve, a normal distribution curve. So let's just take a look and see what actual figures have we been given, what data have we been given. And in this box we are given the weight of all the adult workers in a factory. Okay, so their weight, and it's given in pounds. So not stone or not kilograms, it's given in pounds. And in the first column there you'll see that between 85 and 105 pounds we have 36 workers in that category of weight. Between 106 and 126 pounds we have 58 workers. Between 127 and 147 pounds we have 88 workers. Between 148 to 168 we have 178 workers, and on it goes all the way up to 231 pounds. That's where the data runs out. So if the question is, so let's just zoom out a little bit. If the question is to find the mean, now let me move this. Do that now. Oopsie daisy. To find the mean, how do we go about it? Well, at the minute, the data that we have is not very useful insofar as we have these groups of figures here, like 85 to 105. Or 106 to 126. That's not much use to us. We need to get one number, not two numbers. We need to turn that into one number to find the mean. And how we do that is to basically recreate this table up here and get new figures in these boxes here using mid-interval values. Mid-interval values. Okay, so mid-interval values are when you take these two numbers and get the midpoint of them, basically. So let's take this first box here, this 85 to 105. If I add those two numbers, I would get 190. And if I then halve that number, so in other words I divide it by 2, I would get 95. That is my mid-interval value. That is what I'm going to put in here instead. So instead of using these two numbers, I'm going to use the mid-interval value for it, and that's 95. If I do the same for this box here, which corresponds of course to here, I would be adding 106 to 126. That would give me 132. Halve that, and I am on, it wouldn't give me 132, would it? It would give me 232. That would give me 116. So that's the number that goes in here. And on and on and on, if I continue doing that, I would get 137, I would get 158, I would get 179, I would get 200, I would get 221. So now I have a frequency table that I can use to find the mean. Okay, I couldn't really use these figures up here to find the mean, whereas I can now using this table. Okay, so what do you do to find the mean. Now, ideally you use your calculator, so you know all the buttons on the calculator, and we'll go through that in a minute. But essentially what you're doing when you're finding the mean is you're getting the number here, which is 95, and you're multiplying it by the number below it, which is 36. And then you're adding that on to the number there, being multiplied by the number below it. You're adding that on, and you're repeating this. So it's basically top by bottom plus top by bottom plus top by what's underneath it, or by the bottom, plus top by bottom plus top by bottom, all over, all being divided by all of the bottom numbers added. So 36 plus 58 plus 88 plus 178 plus 160 plus 81 plus 20. And you would type that all into the calculator, and you would get, as the mean, you would get 99,588 over 621, which if we type it into the calculator, it gives us a mean of 160 pounds. Okay, so that's the average weight. Now I did a small bit of rounding there on the mean. It was 160.367, blah, blah, blah. But let's call this the mean. Okay, so that's the average weight of somebody working in that factory. Okay, now I did it the old-fashioned way by just writing out the mean. You can do it on the calculator if you were shown how to do it on the calculator with shift, mode, 2, 1, etc. depending on what calculator you use. But there are certain buttons that you can press just to get you the mean. And we will be using the calculator to get the standard deviation in a minute. So we will come back to that. But that is the mean. That's the average weight of somebody working in that factory. Okay, we've done that. Now, next question. Find the standard deviation. Okay, and you'll often see this little symbol here being used to show standard deviation. That's a sigma. It's like a Greek symbol that we use in maths to symbolize these things. The one for mean is this little X with a little bar on top, or X bar. Okay, that's the symbol they use for mean. Okay, so we found the mean there. Now we're going to find the standard deviation. Now, to find the standard deviation on, let's say, most people would have a Casio calculator, and it would be the FX GT, could be the 8.5, could be an 8.3, but everybody's is different. I'm going to use the one that I have. And when I input all those buttons, and there's another video on how to find the standard deviation using a Casio calculator. So if you're not sure about that, you can look at the video. But when I type in all those buttons, I get a standard deviation of 30.4. Okay, 30.4 pounds. So here's my, I'm going to do that in purple. Here's my standard deviation, 30.4, and here's my mean, 160. What does all of this actually mean when it comes to answering these questions in statistics, or just in general? What are we actually looking at here? Okay, let's have a look. What it means is, if we were to chart the people's weights and basically design like a trend graph, or mark down what people's weights are. Most of the people would be in this area here. That's why we call it the mean, the average weight. Now, what did we find it to be? I think we find it to be 160, wasn't it? 160, yeah. That's the mean weight. So that goes right bang in the middle there. 160 pounds is what most people weigh. Now, we found the standard deviation to be 30.4, didn't we? Yeah, 30.4. So that means in this box, to the means left over here, what number goes in there is essentially the mean. I've drawn a little symbol here. The mean, now we know what the mean is, it's 160. The mean minus the standard deviation, minus 1 standard deviation. So in simple terms, that's a 160, the mean, take away, oh God, what's after happening there? No idea. Go back. I don't know why that has happened. I think that's fixed it. The mean minus 1 standard deviation, so minus 30.4. That would leave 129.6. That's what goes in here. 129.6. Now, what will go in here? Well, that will be another, we deduct another standard deviation from the mean. So we could do it this way. We could say 160, take away 30.4, and then take away another 30.4. And that'll give us our answer. Or we could just simply get this number that we've already gotten, which is 129.6, and take away another standard deviation from that. What do we get? We get 99.2. So that's what's in there, 99.2. And likewise here, we get our 99.2, and we take away another standard deviation. What does that give us? It gives us 68.8. So 68.8. And the other direction, this direction from the mean, okay, up from the mean, we're actually going to be adding standard deviations, not minusing them. So in here, we get our mean, and we add on a standard deviation. That gives us 190.4. So that's what goes in here. 190.4. And in here, we're going to add on another standard deviation. So 190.4, add on another standard deviation. That leaves us with 220.8. So that goes in there. And then in here, we put in another standard deviation. 220.8, add on another standard deviation. We get 2, and 1 is 1, and 5 is 251.2. Now, here's the good question. What does all this mean? Well, we found the mean of the weights of the people in the factory, and it was 160. Now, does everybody in the factory weigh 160? No. It's just that most people in and around weigh that. And we can be very specific. One standard deviation below the mean, up to one standard deviation above the mean, that is where 68% of the weights of people in that factory are. And then if we go down another standard deviation, so 1, 2, and up to, in this category in here, we have captured, so all in here, we have captured 95% of the people in that factory, the weights of people in that factory. Okay, so a normal distribution curve is just a way of representing the normal data that you'd find in such a finding. I mean, you're not going to get people that are 40 stone or 1 stone. people will fit